The agenda for today is I just want to do a quick survey and see how many of you already write App Engine applications. So if you created an application, very good. And how many of you have never created an App Engine application? Okay, good mix. So I want to do a little introduction for those of you who are not familiar with App Engine. Then just kind of a brief highlight of some of the big features. But then I want to quickly get into what's new on App Engine and then some best practices. So if you're building an application, what are kind of some of the special tricks or the things that you should know and the tools that you should use to make your applications better. And then maybe we'll have some time for questions. If not, you can meet me or my colleague Iein Valdez in the office hours. So let's start with a little quick introduction. Many of you have built applications before, have probably done so on a LAMP stack. So you're using Linux, Apache, MySQL, and then something like PHP or Perl, or some language which starts with the letter P. And after a quick amount of time, you probably discover that you're spending a lot of time doing maintenance on the servers. You have to set up new servers, and then the server crashes, and you have to patch it, and then there's a new vulnerability, and maybe your server gets hacked. It's just a lot of work. When really what you want to do is build applications, because that's why you're a developer. So we bring App Engine to the rescue. We have this SDK that you can download, install, run locally, and then you can deploy your applications to the cloud. We have certifications, we have runtime languages, we have a language with a P, Python. We also have a new experimental language called Go, which some of you may be interested in, and it's pretty interesting as well. And of course, Java for enterprise developers or anyone else who likes Java. Now, when we set out to build an App Engine, we kind of had three key ideas in mind. We said we wanted it to be really easy for you to build applications. This is kind of the primary driver behind App Engine. We want you to be productive. We want you making applications, not configuring servers. We want it to be really easy to manage applications. So once you created the app, you shouldn't have to touch it and configure it and turn all the knobs every day. You should just be able to leave it alone and let it run. And when your traffic spikes up or your traffic spikes down, you need the scalability. And that means going up and going down. So when you have no traffic, your website should be very, very cheap to run. And when you have a lot of traffic, App Engine should be able to handle the scale. So we put this all together, and you kind of get this. We let you focus on productivity so you can build applications without the headaches, because we don't really need headaches. So I want to do just a quick demo for those of you who haven't seen App Engine, haven't seen the local SDK. And what I'm going to do is just jump into Eclipse, and I'm going to create a brand new project. And let's just call this prog. We'll do an App Engine only project this time. And this creates a simple template with a servlet all pre-configured for us. And let's see, here it is. And you can see we do not much else than hello world. So let's make this a little more interesting. And let's run this locally. So just on this machine right here, we're going to run this application. And we have all the APIs emulated for App Engine. So we can use the scalable data store, although it's not an entire data center inside my laptop, just a tiny data center. So here's the servlet. Okay, great. Let's deploy this now to App Engine. And we just have to tell it an application ID. I already have one. So I'm going to deploy it there. Now, in the few moments that this takes to deploy, I want you to think about how much time you would spend setting up a LAMP stack. LAMP stacks are great. You can configure everything. LAMP stacks are great. You have to configure everything. Every piece of software that you need to install, you need to maintain and update. So let's see if we're already there. I wasn't watching how quickly it was going. And there we have it. So we just deployed to the cloud. And now, if all of you went on Google Plus, on Twitter, on Facebook, or wherever, and you printed this URL and they say, you win $1,000 if you go to this URL, and everyone jumps on, App Engine will just handle that load, spin up more servers, and serve the traffic. And if nobody goes to this website, we'll run 0 servers, and we'll start worrying about one of those other 200,000 applications. So that's really kind of that make it easy to build, easy to maintain, easy to scale. That's what I showed you right there. So App Engine is kind of going through a new phase. We launched about 3 years ago in 2008, and back then we were kind of a fun platform, but to some developers the future was a little bit unclear, and so we wanted to provide some more certainty to you. So we're getting out of labs, we're taking the preview label off the product, we're becoming an officially supported product, and that means a number of things. That means we're going to give you a 95.95% SLA, a service level agreement, paid operational developer support. We have these certifications if that's important to your business. And of course, we're growing really, really fast. You saw the graph earlier. Now we have our third runtime. We have all these features. We have a new data store. If you follow the App Engine blog, you'll see that pretty much every month we're launching some pretty significant features. In fact, the last few months we've been doing a new release every month. So let's look at some of the base features. We kind of have 4 categories. We have compute or computation. This is where your program executes and you do things like handle user requests or process very large amounts of data. We have persistence, or the storage. This is where you put your user's data. This is where you might put files or blobs, but also the Cloud SQL, so you can do relational type queries. And we have static content that we can serve very efficiently. You know, Google has a global network of a large number of data centers, and of course, we serve a lot of content, so that's something we do well. Then we have ways of interacting with other services, because cloud apps by themselves aren't as interesting as cloud apps that are integrated with others. So we can do URL fetch and other services like that, which I'll talk about in a moment. And then we have a growing number of APIs on the platform. This is where you're really starting to see the platform as a service being leveraged. Now, as a developer, you're on App Engine, you're building things, and then suddenly Google releases a new API, like the prediction API, and you can just incorporate that into your application. There's no additional software to configure. You just have the latest SDK, and you can call the different APIs. And over time, we keep adding to these APIs, making the existing APIs richer. So this is kind of the picture that we're drawing, and we're starting to fill it in and add more and more capabilities for you. So let's dive in a little deeper to some of these. On the compute side, we have what we call front ends, back ends, and then we have task queue and cron. Front ends are the app servers that serve user requests. So user makes a request to your application, and then we need to execute your code. We do that on special servers that we call front ends. And those are the ones that scale up and down automatically with your traffic load. We also have back ends. They're a special type of server that is more configurable. You can add, specify the capacity. You can have a larger server that runs faster or has more memory. But backends can also be public. This allows you to directly access those backends. For asynchronous tasks, we have task queues. This is a way for you to take work that you want to do, but you don't want the developer or the user to wait for that work, and you want to do it in the background. This is also a way for you to kind of harness Google's tremendous parallel scalability. The fact that we have large data centers means that we can run a lot of workload in parallel. So you have an application, you may only have 5 users hitting your app. And you may only be using one front end to kind of serve that traffic. That's pretty small. But maybe back in the data store, you have 10 billion entries. Maybe it's all the comments from all the blogs from all your users who have subscribed to your blog site. And maybe you want to process those comments. You want to change something, or you want to do some analysis. Maybe you're building out a data set for the prediction API. What you can do is tell App Engine to map over all those entities. That is, create a tiny little task, a little checklist, as it were, for every one of those entities. So now you have, I think I said 10 billion entities. So App Engine will create 10 billion tasks, and it will just start throwing them on the task queue as quickly as it can. And your application or App Engine will see this very large number of tasks, and it will treat it as if 10 billion users are sort of showing up in queue trying to get some work done, and it will spin up more instances of your application to try to process this work. And then inside each one of those tasks, you can do some work. You could make a call to another service. Maybe you're trying to copy the comments over to some other system. Or you can process it. You can do all sorts of interesting things. So for a long time, we've had push queues. Push queues take the work that you create, and they push it down to your application. And your application spins up more instances, and then when the work's gone, those instances shut down. We also have something new called pull queues, which work a little differently. There, the queue just sits there, and then your application goes and takes work off the queue, processes, and then deletes it, and then grabs the next section. The nice thing about pull queues is you can interact with external systems. So you have maybe a process that's doing something on App Engine, and then you need something else to happen somewhere else. You put that work or that task on the pull queue, and then some other system can come around and say, oh, there's some work, let me grab that, process it, and put it back in the queue, and then App Engine can grab it. So it's a way of doing synchronization. Now, on the storage side, we have the high replication data store. It's a schemaless data store. That means there's no global schema. Every single entity or every row in the data store has its own set of properties. It's an object data store with entities and entity groups. It has a query engine, so you can run select statements, and it has indexes, and it can find data based on properties that you've set. It provides for atomic transactions, so you get consistency, and you can know that when you've written some data that you can read that data back. And it's, of course, very scalable. It's built on Google's infrastructure. We commit your data to multiple data centers simultaneously. So even if a data center goes up in flames or it goes off the net because someone cut the fiber wire, we still have your data in other data centers, and we can continue serving your application. So it's very reliable. Now you saw in the keynote earlier the Cloud SQL announcement, and the fact that you can now use a relational database as well. And you can use those at the same time. You can have the high replication data store for very high scalability, and the relational data store for that data where you'd like to do joins and do kind of the traditional model. It's fully managed. That means our team of site reliability engineers is constantly monitoring the service and keeping it up. That's part of this platform as a service offering that we have. Highly available because we do that synchronous replication, and we do that for Cloud SQL as well. We have it integrated, so even for Java and Python, there's either JDBC or the DB API to connect to it. And you can migrate by importing or exporting your existing MySQL databases. So currently this is something like MySQL 5.1, and other than functions and stored procedures, all the other features should just work. So you can create tables, drop tables, do joins, all the fun stuff that SQL developers want to do. Now, for interacting with other systems, we have URL fetch. It's basically RESTful interface to other systems. So you can do HTTP, GET, POST, PUT, etc. And you can just talk to any system that you can on the web. And increasingly, all the APIs out there are really RESTful interfaces. And there's two modes of operation, synchronous and asynchronous. Synchronous, of course, makes your program wait for the answer. Asynchronous allows you to do multiple things at once. So if you want to fetch the results from 3 different pages, you can do that all at once and then wait for all 3 results to come back. And that will make your application faster. Now there's a large number of APIs, so I don't want to go through all of them. But I want to show one of them, which is kind of fun, which is the Images API, where you can do rotation and cropping and all the typical things you expect from the images. But we have one really neat feature, which is you can take an image, like a large raw image that you grabbed from your camera, you can upload it to Google App Engine, and then request a special URL, a serving URL. And App Engine will give you back this unique URL that you can use. It's public URL. So you can include it on your website and then will serve that image for you. Now that's just static content serving, but what makes it really interesting is you can provide a size parameter at the end of the URL, and we will dynamically size the image for you and cache it. So if you have maybe an image like someone's profile picture and you want to show it on a small form factor device and on a tablet on a PC, and you want to be able to size it dynamically based on the device or the user interface, we'll do all of that for you. You don't even have to crop the image. You just give us the size parameter and we'll do it for you. Okay, so I promised we'll get quickly into what's new and best practices, so let's kind of do that. I hope you have kind of an idea of what App Engine does, and maybe some of these new features will entice you to try those out. So I can't really talk about new unless I talk about the latest App Engine release, which is 1.5.5. And because there's some really, really cool things that we've done in there, especially for those of you that have been on App Engine for a while, you'll be like, yes, finally. And the first one of those is the cross-group transactions. And I'll talk about this in a little bit more detail. But we finally allow you to do transactions across multiple entity groups, which totally changes the number of things you can do in App Engine, changes the way you have to or kind of design your entity model in the data store, and just lets you do many more interesting things. We launched in experimental form the Python 2.7 runtime, which means Python developers can now do concurrent requests. That allows them to use the front-end instances much more efficiently, and it'll make it much more affordable. And of course, you get the latest features in Python 2.7, like you don't have to download the separate pill library for image manipulation. All that's kind of good stuff that comes with 2.7. The Cloud SQL I mentioned, we have a trusted tester program for full text search. So taking text data in properties in your data store and actually being able to do proper searches without having to build your own indexes. And then we have a new migration tool for high replication customers. So people who, if your app is on the old master-slave data store and you'd like to get over to the new high replication data store, and trust me, you want to be on the new high replication data store, much better. We have a migration tool. And what we do is we basically allow you to take your data, copy it while your application is still being used, and then we keep track of all the changes that are happening while the copy takes place. And that takes some period of time depending on how much data you have. And once you've done that, you can go through another iteration and say, well, just copy the stuff that changed since I started copying. So you get a smaller copy. And you can do that a number of times until you get to the point where there's just a very small amount of data. And then you press one final button and you say, okay, make my old application read-only so the data store can't be written to, copy the last bit of data, and then switch the traffic to the new site. And then you're migrated. So for a very short period of one-time maintenance, you can now migrate your data from the old application to the new one. You still get to keep the domain name and the URL that you had, but now you get this new data store and the replication. We also increased a number of the limits that some of you have been running up against. So file upload size and front-end requests go from 30 seconds to 60 seconds, which is doubling what we were doing before. And this is really important for those of you building with Google Web Toolkit and applications that generate a lot of files. We're going from 3,000 files to 10,000 files within your app. So that makes a big difference. And then we have the storage API and a change in the admin console where you can actually see the number of instances that you'll be billed for. Other kind of small improvements, but certainly worth noting, is that on the Blob Store, we allow for unlimited size. Previously, it was something like 2 gigabytes. Now you can make terabytes, petabytes, whatever you want to send. Although petabytes might be difficult over the internet. Maybe we need a faster connection. In Python, we added the CAS capability. This is compare and set. It's a way to kind of atomically update a value only if the value has not changed since you last saw it. And it allows you to do some interesting things. This was previously available for Java, but now it's Python as well. We have the asynchronous memcache, so you can make multiple memcache calls in parallel. And then there's a little helper function for Python developers in DB model, where you can take all the properties and convert them to a dict. And that makes them a little bit easier to manipulate. You can deploy configuration changes to your backends without shutting them down and starting them up, so that's pretty useful. And this is really, really nice. SDK eventual consistency simulation. That means that in your local SDK on your laptop, you can set a flag and you essentially simulate eventual consistency. So then sometimes when you do a write, global queries will no longer see that write right away. They'll catch up kind of a little bit later, and it allows you to kind of test your application for these rare scenarios where you'll see the eventual consistency and make sure you're doing things correctly. We do country identification for you, so for every browser kind of hitting your site or mobile client, based on the IP address, we can figure out with fairly good accuracy what country it is, and then you can change your UI based on that. Maybe show a different language, do specialized content for that region, and so on. And then I know this was a pain before, is the admin console would show logs in California time. Fantastic for me, because that's exactly where I live. In fact, I moved there because of the, no. So now you can pick your own time zone and see the logs in a time that makes sense to you. Now I want to take just a little bit of time and talk about some of the improvements that have been a little bit hidden to many of you unless you've been taking very careful note of the release notes. This is kind of some of the transparent improvements that we are constantly making to the platform that make your life better. The problem with this improvement, though, is if you're an existing developer in App Engine and you were aware of the previous limitations, you're probably kind of building around that. And now you don't know that actually those limitations have disappeared. So I want to talk to you about briefly so that you can go back and maybe adjust your applications, maybe add some functionality or remove some code. So the Advanced Query Planner, what is that? Well, App Engine has a query planner. That is, when you give App Engine a query and say, I want this data, App Engine has to decide how to get that data. It has to look at the indexes you have defined for your application, it has to look at the query, and then it has to somehow scan the data store, find the data you're looking for, and then give it to you. And there's often more than one way to find that data. So the query planner's job is to figure out what's the right way to find that data. And what we did in 1.5.2, 1.5.3, and a couple of improvements after that, is we've greatly improved that query planner so it can take advantage of simpler indexes and give you results that previously required very complex indexes and kind of bumped up against the limits. If you know what exploding indexes are, then you've run into the issue I'm talking about, and you'll be very interested in the answer here. Exploding indexes are basically indexes that as soon as you add more than a few values, they explode in size and they're really not manageable anymore. This often happens on list properties. You have a property maybe with tags. Let's say you have a photo album and you say, well, I'm going to tag this picture here. And this picture it's outdoors, it's in the park, and it's with my family. So that's 3 tags. So you put 3 words on it. If you have multiple indexes on the tag field and you want to do searches across multiple properties, you'll need composite indexes that reference the tags field multiple times. And these explode in a way that I'll show you in a moment to where you get such a large number that it no longer makes sense. And it really prevents you from writing queries. In addition to fixing kind of the query planner production, we also updated the SDK to understand the improvements so it no longer tells you that you need an index when you don't. And so you can kind of do the development locally and get an accurate idea of what indexes you actually need. The way the new query planner works is using what are called zigzag queries or merge join queries. If you don't know what those are, there's a link to a talk. The slides will be available. And Brett Slatkin talks through that process very, very precisely, shows exactly how this works. And then once you understand it, I think it'll be pretty easy. So let me make a concrete example, because I've been talking about it a lot, and it's maybe a little bit abstract. So I apologize for that. But imagine you have a photo site, and you have all these photos, and you have many, many users of the site, and you want those users to be able to query for their own photos, or maybe other people's photos. And so you give them this search UI. And you say, well, I want to be able to search by the owner of the photo, maybe the size, whether it's small, medium, or large, the aspect ratio, narrow, wide, whether it's black and white or color, and so on. I also have these tags, the family, the park, the outdoor photo. And then I want to order the results, maybe by, let's see, how they're rated, or number of comments, or number of downloads. So a pretty simple user interface, pretty decent requirements, but you'll see how in the old query planner, this fell apart pretty quickly. So what you needed before we made the improvements is you needed first an index for each of the properties. So if you wanted to search by owner and be able to sort by date, rating, comments, and downloads, you would need 4 indexes just for that. Search for all where the owner ID is Fred, ordered by date, descending. That's that first index, and so on. So 4 of those. Then I need 4 more for the size, and 4 more for the aspect, 4 more for the coloration, license. But what I also need is these composite indexes. What if I say where the owner is Fred and the size is medium, ordered by date? Well, then I need one of these indexes. And if I count all the combinations, I quickly end up with indexes like this. The aspect ratio, the coloration, the license, the owner, size, ordered by date. And if you just do the math on all of that, it turns out for this simple form here, with just 1 tag, you need 256 indexes. If I wanted to be able to search for outdoor pictures with my family in them, that's 2 tags, I would need 512 indexes. That's already over, both of these are over the limit of 200 indexes. So this form was really not possible in App Engine before, unless you did some tricks to kind of combine maybe properties or do some filtering within your application. Now I'm going to show you, so remember this number 256 and see what happens with the new improved query planner. The same search form, we start out with the same indexes on the owner and the size, and we go all the way through to the license, etc. But that's really it. We don't have to do any of these composite indexes. We just create several simple indexes, and then what the query planner is going to do is it's going to essentially do multiple queries against multiple indexes at the same time. It's going to find the first entity here, the first entity here, and see if they match. If they don't, it jumps to the next one, doesn't match, next one, oh, there's a match. Return that result, keep going, and it has multiple pointers like that. So it's jumping through the cursor results in multiple points of time and finding entries that match. They're all ordered the same way. So it would take, for example, if we order by date, it would take that very first one, photo owner date, and it would take photo size date and photo license date and photo tag date. And those, let's say 4 indexes, scan them at the same time with 4 different pointers and bring back the results. No composite indexes. Do the math here. Now it's 24 indexes. So if we went from 256 to 24, but in the previous slide you saw it was 256, then 512, then 1024 for just 3 tags. If we do 3 tags here, it's still 24 indexes. We just reuse one of those indexes over and over again. So you can do a lot more now, much more complex searches and still get the results you want. And so one of the things I wanted to point out is that if you have an existing application and you previously built all these composite indexes, they still work, but you're wasting essentially writes. Every time you do a write and you write out 256 indexes, those are 256 operations where you really only need to do 24. So I want to get into kind of a little bit of advice on how to use the new query planner and take advantage of this and clean up your old indexes. So step 1 is upgrade to the latest SDK. Just download it and then turn off automatic index generation. In Python you do it with this flag, in Java you set this property in an XML file. And then remove any custom indexes that you think you might not need anymore. And if you don't know, you're only developing locally, just remove all of them and then see which ones you need after that. And then you test your application. And the SDK will tell you when you actually need an index. So any indexes that you need, you add them back in. And then you carefully deploy to production. And I say carefully because in some cases, even though an index is not strictly needed, it may take a very long time to get the search results. And in those cases, you might still want to add a few composite indexes. And you do that based on the kind of queries that people write in what we call the shape of your data. How many color photos do you have versus black and white? Is that a good index to have? Is it good to maybe have a composite index that includes color? So that requires some experimentation. But once you're certain that you have the new configuration, you've gotten rid of the extra indexes, then you can run appconfig vacuum indexes, and the little vacuum cleaner comes along and cleans up all the indexes, deletes them. No sound though, it's very quiet. The next cool feature, this is the one I was most excited about, is the cross-entity group transactions, or the XG transactions, coming out with 155. And this really changes the way you interact with the data store. If you go to Iein's talk later about the higher application data store, you'll see he talks a lot about entity group management. Trying to decide whether you put all your data in one entity group or many entity groups or some number in between. And this has always been a really hard trade-off to get just right. Now with XG transactions, it becomes much, much easier because you can kind of have both worlds. So what are XG transactions? They allow you in a single transaction, so atomically either everything commits or nothing commits, you can update up to 5 entity groups. It doesn't matter, they don't have to be related, they don't have to be the same kind, just any old 5 entity groups. It does, and you can do 5 ancestor queries and have those be strongly consistent. You can get concurrency exceptions though, and this can happen when there are other changes going on. If you are kind of a little bit familiar with App Engine, you know that App Engine uses optimistic concurrency. That's kind of in contrast to relational databases, which use pessimistic concurrency. In a relational database, what typically happens is when you want to change a row of data, the database locks that row, an exclusive lock that only you have as a process. Then it allows your process to make the update, and then it releases the lock. Now this process, it doesn't scale very well because if you want to make a change, you basically have to stand in line. There may be 3 clients in front of you that all want to modify the same row, and you just sit there and wait. And this one, they lock the row, they make their change, they unlock, and then you come. And very quickly you can get in a situation when there's a lot of traffic that the database essentially stops responding because there's all these locks queued up. So in App Engine we use optimistic concurrency, which is that all those transactions that are trying to get to the front of the line, we let them all try it once, and only one of them will succeed. The others will get a concurrency exception, and then usually for writes that are not transactional, we retry them. So let's say we have 5 clients. They all want to update the exact same row. 5 will try, 1 will succeed, and 4 will get an exception. Then those 4 will retry, 1 will succeed, and 3 get an exception. This happens all in a very small time period. It may be hundreds of milliseconds, it may be a few thousand milliseconds. But then those 5 all succeed, and everyone's happy, and everyone goes home. Now with XG transactions, you're actually involving multiple entity groups. So what might happen is I access my first entity group. Let's say there's 3 that I want to update at the same time. So I access my first one, everything's still okay. I try to access the second one, and at that point, I realize that the first one has actually changed. Someone else made an update while I wasn't looking. At that point, I'll get a concurrency exception, and I have to try again. So I have to go back to the first one and say, oh, let's try to update that one again. Let's try the second one. Let's try the third one. Okay, everything's good, and then we commit our transaction. The thing that might surprise you initially is that you can get those concurrency exceptions also for reads. So if all you're doing is making, say, 3 ancestor queries for 3 different entity groups, you do that inside of an XG transaction, what will happen is the data store will go kind of get the results for the first entity group, pull those in, It's going to the second one, it's getting the results and says, oops, first one changed, and then puts everything back and says, okay, you have to try again, concurrency exception. So once you understand that and it sort of makes sense, then you can deal with it. But this allows you to do very cool things. It's only available for high replication data stores. Yet another reason for you to migrate. It's in 155. And let me just show you what that looks like in Python. So we have a simple DB model. It's an account, a bank account in this case. And the key of the bank account is the account number. So I don't need a property for that. I only have one property, which is the balance. And that's how much money I have in my bank account. The really only new thing that you have to add to your code is the single DB transactional XG is true. That means I want a cross-entity group transaction. I want to be able to transact against more than one entity group, up to 5. And then the rest of the code is typical. So I have this transfer funds method, and it's going to take money out of one bank account and put it in the other. So I go to the data store and I grab the two accounts. I move the money from A to B, and then I put both entities to the data store. Now this will happen atomically. Either the money gets removed out of A and put into B, or nothing happens. I never get an in-between case where only one of the two things happens. So you can see that with XG transactions, suddenly I kind of break open the boundaries of entity groups and I can do whatever I want. It's pretty cool. Okay, so those were kind of some of the new things. Now I want to show you just some of the best practices. These are the tips that I end up giving out the most to developers who I talk to, say, oh, how do I do this, or I'm having this kind of problem. And I've ordered them a little bit by the most interesting ones or the most useful ones to the lesser ones. So the first thing you do, if you have any questions about the performance of your application, how to tune it, how to understand it better, or how to ask a question about it, is to run app stats. And when you enable app stats in your application, you get these graphs that will show you exactly, for this case, this is one HTTP call, what's happening, what RPCs are being made. Here we're going to the data store to do 3 gets, then 3 queries, then a couple of gets, and so on and so on. We can see exactly how many milliseconds each of those calls took. We can also see how many calls we're making. So maybe we shouldn't be calling the data store 3 times sequentially. Maybe we can combine that into 3 parallel calls so they can happen at the same time. Or maybe I don't need to run 3 queries. Maybe I can run 1 query and get the answer I need. Maybe I can use memcache and get a response much faster than going to the data store. That first call, I think it's 83 milliseconds. That's a long time. Memcache you can probably get in 2 or 3 milliseconds. So those sorts of improvements you can see right away here without having to look at any of your code. One of our users even commented and said, this is fantastic. He says, I used to be blind, but now I can see. I can see what's happening inside my application. Now, many of you that have built your applications then want to test it. You're about ready to launch, your user is growing, and you want to understand, how do I load test my application? How do I make sure that the application is ready to serve traffic? And I haven't made some mistakes, like create a lot of data store contention on single entities. So I have an easy recipe for you to copy down or take later. And it's as simple as this. First rule is your traffic has to be representative. It has to look like real traffic. Mistake a lot of people do is they say, well, it's too hard to create 1,000 test accounts. I'm going to create 1 test account with 1 test user. And then I'm just going to have a lot of machines all log in as that 1 user and try to do stuff. So I have 1,000 sessions from 1 user. Well, that's not very realistic because 1 user doesn't normally log in from 1,000 different places. And you can actually run into some problems here because that user has specific data, and that data is probably in a specific entity group. So now you have 1,000 sessions happening, all trying to access the same entity group, and you're going to get data store contention and errors that you don't expect. So the moral is here, make sure the traffic is representative, it's real, it's the sort of things that users are actually doing. Every user is not going to the home page and hitting refresh. Users are navigating through your site, they're creating data, they're looking at data. The second kind of rule here is you ramp up over several minutes. And by that I mean don't do this. A lot of people do load testing this way. They say, okay, I have no traffic to my site. Now I'm going to hit it with 100 requests per second and see what happens. Well, normal users don't come to your site this way. Even if I asked everyone in the audience to kind of go to one URL, the speed at which we can get out our phones and type the URL is different. We might not be ready at the same time. This effect is magnified when there's real people out in the web. So traffic doesn't really look like this. This is a much better load test, much more representative, and you'll get more natural response. And this is kind of the ideal that you're going for, which looks a lot more like the real traffic graphs well. Now the recipe is very simple. Is you start your load test probably around 5 QPS, that's 5 requests per second. And this allows you to uncover basic problems, like you have a global web counter that is locked by every single user. When you run in those types of things, you'll very quickly find them just at a simple test like this. Once your traffic is up and going, then you want to look for a few things. You want to see 0 quota denials. You want to see a low error rate. You want your requests to be fast. And you want to make sure your task queues are not queuing up. So you're not having more and more task queues show up on the queue. If everything's running smoothly, usually 15, 20 minutes, but sometimes you can call it earlier. But once all the graphs are kind of steady, then you know your site can handle 5 QPS, which hopefully it does with no problem. And then you double the traffic. And you just keep doubling it. So you start with 5, then you do 10, 20, 40, 80. And very quickly you can get into very high numbers. And you essentially stop when you've reached the amount of traffic that you expect or reached the amount of load testing that you want to do. And then you plan your next feature. And then you test it. And this is the recipe. Start at 5, test for 15, 20 minutes, ramping up slowly, and then double your traffic every time until you get to the position you want. Now, I talked to you earlier about Memcache, and I wanted to draw a picture for you to make that visual. Imagine here you have on the left, you have a client coming in, a user, they're making a request for your website, and they want an answer. They want a web page, they want a result. And then you hit the front ends or the back ends where your code is running. Now your code has to find the data that the user wants and give it back to them. Your code is a decision to make, though. Does it go to disk and get the data off of a platter somewhere, or can it go to memory? It's about an order of magnitude faster. So you can see here that even if some of the results can come back from Memcache, that you can make your application much, much faster. Every large application on App Engine is using Memcache. And I would say every poor performing application, or most of them, are not using Memcache. So it's just a simple rule, use Memcache. And what you want to do is put data there that is going to likely have a cache hit. It's a least recently used cache. So the more frequently your data gets a cache hit, the more effective it is. So it's a kind of a self-rewarding system that the better you use it, the bigger the benefit that you get from Memcache. Now, I know it's not quite lunchtime yet, so you're probably thinking, why is there a big sandwich on the screen? And that's because we have this English saying, which is there's no such thing as a free lunch. That means, maybe you can get a free lunch somewhere, but there's always something attached. You have to do something, or there's some extra work. You can't really get a free
lunch. And I want to tell you that maybe you can with App Engine, or you can on the web with caching. Actually, for a very tiny amount of work, you can get a free lunch. So free lunch opportunity, and your users will be happier. You should use Memcache, but only use it if you care about your users. If you don't care about them, don't worry. Use static resource files instead of dynamic ones. You saw the picture with the front ends and the back ends. If you use static content on App Engine, you don't even use front ends and back ends. So you don't use any instance hours, and we can send the content back to the user faster.
Most important thing here, use HTTP 1.1 caching. Standard cache control header works everywhere in the web, works really well in App Engine, and it means that content can be cached by the user's browser, by the ISP and their servers, and on App Engine. Now think about this. You have some large images on your site, like maybe the logo, and every time App Engine takes that logo and sends it to the user, those are bytes that have to go from Google all the way to the user, down the internet, down the clogged tubes, and that's quite a bit of waste of time when those bytes are the same every time. When you turn on caching and you have two users who are maybe neighbors or they live in the same neighborhood or they have the same internet provider, that internet provider can cache that content and serve it immediately to the user. That way your application doesn't get hit, the bandwidth is not needed, and the response is faster. And like we like to say, that's a free lunch. Now, just a few best practices for client-side code. So many of you maybe use App Engine to write backends for your Android applications. And in your Android application, you have to call home. You have to connect back to the cloud and make some requests. But there are a few common mistakes that people run into. And oftentimes people see a graph like this. And that is essentially all the clients may be checking in at a specific time of day. Maybe you decided that the website is, or users are always asleep in the middle of the night, so at 2 o'clock in the morning, you're going to have your application call home and ask for any updates. Except as your application becomes popular, it turns out a lot of requests coming in at the same time kind of looks like a really bad load test. So what you want to do instead is kind of spread out the load, randomize the check-in times. So each owner of an application gets a random check-in time, and then you won't have this problem. The next thing people run into is they see this kind of heartbeat profile, and it usually happens after they've been functioning well for some period of time, and then there's some kind of outage. Maybe they took the app down, maybe there was some network problem, and then when the application comes back up, all the clients have been kind of disconnected, and they do a retry. And what's the easiest thing to do in a retry? Is you just try again, or you sleep for 2 minutes and then try again. Now, if every single client sees an error at the same time and they all retry after 2 minutes, most of them are going to fail because they're all retrying at the same time. That's a bad load test again. And so every 2 minutes you kind of get this spike, or every n amount of time. So instead of doing that and avoiding this denial of service on yourself, use an exponential backoff. And that just means retry after 1 second, 2, 4, 8. You keep doubling. And this allows the traffic to very quickly dissipate into very low levels, so your service can recover. Any other services that you connect to, they can recover, and then clients can slowly start coming back together. In addition, you probably want to use a fuzz factor, randomize it just a little bit. On server-side code, we have this article managing resources, and we have some best practices. I won't go into all of them here, but we update this article regularly, and it has a great number of tips on how to make more efficient use of App Engine and how to essentially save some money, save some resources, and make the applications faster for your user. One of the things I do want you to remember is enable concurrent requests. They're off by default in Java applications. So if you're using Java, you have to go into your App Engine Web XML and you have to turn on concurrent requests. Much more efficient. Just make sure your code is thread safe. You can use discounted instance hours. So if you know how many instances you're going to use, you can prepay for them and get a discount. And then we have some new scheduler knobs in the admin console where you can kind of control the slider between cost efficient and performance. So by default, we're kind of in the performance setting. We want users to get responses to their requests very, very quickly. But some smaller applications that you're building, maybe toy applications, maybe ones that you want to run on a lower budget, you may be more cost sensitive and want to turn down that setting a bit. On the storage cost side, there's a lot of things that you can delete or get rid of. Of course, all the indexes you just vacuumed up earlier, entities that you may no longer need, old logs, that sort of thing, blobs and tasks. And you also want to probably take the indexes off of a lot of properties. If you have a property that you don't need to search on, then you can probably convert that to an unindexed property. And that will save you at least 2 data store writes. Every property by default has an ascending and a descending index. So every time you change that property value, App Engine has to write the property, and then it has to write the ascending index and then the descending index. When you have a lot of properties, especially list properties, that can add up pretty quickly. And these are all just more tips from the article. If you can, enable warming requests for your application. It allows the scheduler to kind of schedule apps more smoothly. And it's simply done by, you can do this in your web.xml file there. And then I'm going to leave some more tips for you to read later. And what I want to hear from you, hopefully by email or on Google+, is essentially which application you're going to build next. And I know we have another session. We're running a little bit late, so it starts in a couple of minutes. So I'll let you go, and I'll take the questions in the office hours. Thank you very much.